Welcome to our lesson on variables. Think of a variable as a labeled container in your computer's memory. Instead of memorizing raw data, you give that data a name, like user_score or player_name. This allows you to store, retrieve, and change information easily throughout your program. It is the fundamental building block for managing data in Python. To visualize this, imagine a labeled box. The box itself is a spot in your computer's memory. The label on the outside is the variable name you choose. Whatever you put inside, a number, text, or a list is the value. When you call the variable in your code, Python looks for that specific label and retrieves the content stored inside that box. In Python, we use the single equals sign, known as the assignment operator, to create a variable. Unlike languages like C++ or Java, Python uses dynamic typing. This means you don't have to tell Python whether a variable is a number or text. You simply assign a value, and Python figures out the type on the fly. It makes your code cleaner and faster to write, as the language manages the data type behind the scenes for you. Variables are not permanent. The word variable actually implies that the value can change. Here, we set score to 10, but then we update it to 20. Python replaces the old value with the new one. When we print score, we get 20, because the computer always keeps track of the most recent value assigned to that label. Sometimes you want to initialize several variables at once to keep your code concise. You can do this by listing the variable names on the left, separated by commas, and the corresponding values on the right. Python maps them positionally, so x becomes 1, y becomes 2, and z becomes 3 in a single line of code. In programming, we often use constants for values that shouldn't change, like a maximum user count. While Python won't strictly stop you from changing it, the convention is to use all caps. This is a visual signal to other developers that this value is meant to be permanent throughout the program's life cycle. If you ever get confused about what kind of data your variable is holding, you can use the built-in type function. Passing a variable into type returns its data category. In this example, it returns class str, confirming that our variable is indeed a string. It's an essential tool for debugging your code when things behave unexpectedly. Strings are used to store text data. In Python, you can define them by wrapping your text in either single or double quotes. It doesn't matter which you choose, as long as they match. Keep in mind that strings are immutable, meaning the specific content of that string object cannot be modified after it's created. For mathematical operations, Python uses two primary numeric types, integers and floats. Integers represent whole numbers like 25, while floats include a decimal point like 19.99. Python automatically recognizes these types based on the presence of a decimal, allowing you to perform calculations directly on these variables using standard operators. Boolean variables are the simplest data type, representing only two possible states, true or false. These are essential for control flow and decision-making in your code. Note that in Python, these keywords are case-sensitive and must start with a capital letter using lowercase true will result in an error because Python won't recognize it as a Boolean. Sometimes you may want to clean up your memory by removing a variable entirely. You can do this using the del keyword followed by the variable name. Once deleted, the variable no longer exists in your program's memory. If you try to access or print it after deletion, Python will raise a name error because the label is gone. The most common beginner hurdle is the name error. This happens when you try to use a variable that hasn't been defined yet, or perhaps you've simply made a typo in the variable name. Python is strict. If the name doesn't match a defined variable exactly, it cannot retrieve the stored value and will alert you immediately. Tip: always use descriptive names for your variables. While a variable named X might work, it tells your future self or a teammate nothing about what that data represents. If you are storing a user's age, call it user_age instead of a. Good naming makes your code much easier to read and maintain later on. Think of a variable as a sticky note attached to a specific spot in your computer's memory. When you assign a value, Python places that data in memory and puts your variable name on it like a label. It's not the container itself, it's a reference. This is why multiple variables can point to the same object. Python has reserved words like if, while, and class that have special meaning to the interpreter. You cannot use these as variable names. If you try, you'll trigger a syntax error. Also, avoid naming your variables after built-in functions like print or list, otherwise, you'll lose access to those built-in features later in your code. Time to test your knowledge. Look closely at these three options. Which one follows Python's naming rules? The answer is B. Variables cannot start with a number, and they cannot contain hyphens because Python would interpret that as a subtraction operation. Only underscore separated words are valid here. To wrap up this lesson, remember that variables are your primary way of storing information. Python's dynamic typing makes them incredibly flexible, but it's up to you to keep them readable. Always stick to snake_case and descriptive names to ensure your code remains professional and easy to understand. Great job on mastering the basics of variables. Let's wrap up what we've learned today. First, remember that variables are simply labeled containers used to store data throughout your program. Second, Python's dynamic typing allows you to assign values without explicitly declaring the data type, giving you great flexibility. Finally, always stick to snake_case for your variable names. It makes your code clean, readable, and consistent with industry standards. To master variables, just keep these three things in mind. Use the equals sign to assign values to your labels. Always double-check your naming to ensure you aren't using reserved Python keywords. And above all, prioritize clarity. If a variable holds a user's age, call it user_age instead of X. With these foundations, you are ready to start building more complex Python projects.